Okay. So, shortest job first. This is one type of process scheduling algorithm. As name says, shortest job first will be selected. That means the process which are supposed to assign to the CPU for the execution, the selection is made based on the burst time of the processes. Okay. So now just I'll just consider this example. See, there are five processes, okay, and the respective burst time is given. Okay, as of now, you just leave this arrival time. Okay, if you look at this example from process 1 to process 5 and consider all the processes arrives at time equals 0. Okay, now P1 has burst time as 6, P2 2, P3 as 8, P4 as 3, P5 as 4. So now compare the burst time of all the processes and find out which one has the least burst time. So when you compare here, process 2 has the least burst time, right? So this particular process will be selected for the execution. That means this process which is in the ready queue will be selected and assigned with the CPU for its execution. Okay. Now, here in this example, I mean preemptive shortest job first. Here what happens? In preemptive shortest job first, jobs will be in ready queue. That point you know already, right? Now, a process with shortest burst time begins its execution, as I explained. The principle of this shortest job first, right? But if a process with even a shorter burst time arrives, say at a given point of time, say when t is equal to 0. Okay, when time is equal to 0, say P4 is in the ready queue. Okay, that is when the execution starts, right? So the particular process P4 will be assigned with execution, right? So when it start its execution, say when time consider time will be increased to 1, time progresses, right? So then you have to check the burst time of the next process which is in the ready queue, compare this with the one which is under execution. Compare it. If it is I mean the burst time of already executing process, if it is lesser, you can allow continuing the execution of this process. Or else, if the burst time of the newly arrived process is lesser compared to the one which is under execution currently, then you have to preempt this process from the CPU and assign CPU to this process if the burst time is lesser compared to the one which is under execution. Okay, that is what this says. If a process with even a shorter burst time arrives, the current process is removed or preempted from execution and the shorter job is allocated CPU cycle. I hope you understood now, right? So now we'll solve a problem by following this principle. Okay, consider there are five processes P1 to P5 and the respective burst time is also given 6, 2, 8, 3, 4 respectively, and arrival time is also given of all the process. Say P1 arrives when t is equal to 2, P2 arrives when t is equal to 5, P3 arrives when t is equal to 1, P4 arrives when t is equal to 0, P5 arrives when t is equal to 4. Arrives in the sense when it enters the ready queue. That means the process which is ready for the execution. Okay, those processes will be placed in ready queue. Okay, so based on the arrival time, you have to schedule the process for the execution considering the least burst time. Okay, let's solve the problem by following the principle of preemptive shortest job first scheduling. Okay, now this is the given data, right? Now let's start when time is equal to 0. T is equal to 0. Which process arrives into the ready queue? That is P4, right? So when t is equal to 0, P4 enters the ready queue. Okay. Now that is what then P4 will be placed in the execution in the Gantt chart. Okay. So next, as time progress, when time increments to 1, that is when t is equal to 1, which process arrives? When t is equal to 1, you can see here, yeah, I have pasted here. When t is equal to 1, P3 arrives, right? But P4 has shorter burst time, it will continue with the execution. See, even though P3 arrives when t is equal to 1, P4 has least burst time compared to P3, right? So P4 will continue with the execution. How long? 1 unit of time. Again, increment time. Now t is equal to 2. What happens when t is equal to 2? P1 arrives. That is, process P1 arrives with a burst time 6. Right? But the burst time is more than that of P4. Now you have to compare the one which is under execution with the one which arrived now. Compare the burst time of these two, 6 and 3, which is least? Obviously P4, right? So P4 will continue its execution. Okay, so that is what represented here. Again, increment t by 1. That means t is equal to 3. So what happens? When t is equal to 3, process 4 will finish its execution. That is, you can see here, P4, the burst time given is 3. When t is equal to 3, P4 will complete its execution. Okay, so this P4 will complete its execution, that is marked here. Okay, next, which is in the ready queue, P3 and P1, right? And these two are compared. When t is equal to 3, the processes which are in the ready queue. First, these two will be compared. Okay. When you compare P3 and P1, see the burst time P3 and P1, which one is the least? P1, right? So now I will assign P1 for the execution. P3, yeah, P1, which is similar, smaller job, that is P1, right? So that will be assigned for the execution. Next, increment the time. That is when time is equal to 4. T is equal to 4, P5 arrives, right? When T is equal to 4, P5 arrives. That P5, now compare the burst time of P3, that is the one which is assigned for the execution P1 and newly arrived P5. All three are compared. Okay. Now, process P5 is executed because its burst time is lower. You can see here the P5, then P3 and P1. When you compare all these three, P5 has the least burst time, right? So that is what it says. P5 is executed because its burst time is lowest. Okay. Then P1 will be preempted. Okay. Now, you have to remember only 1 unit of execution is done with respect to P1. So 5 will be left out of 6. Okay. So 1 unit of burst time executed for P1. So the left out burst time for P1 is 5 now. Okay. Now, when T is equal to 4, 1 second. Yeah. Yeah, P5, when T is equal to 5, what happens? Process 2 will arrive. You can see here, process 2 arrives. The arrival time is 5 here. Then process 2 arrives there. Okay. So when T is equal to 5, the process 2 will arrive. Now compare the burst time of P1, which is here, which is preempted and placed in the ready queue. That is P1. P2, okay, which is in the ready queue, P3 and P5. Okay, sorry, P2, which is arrived just now, right? Compare P1, P2, P3, P5. Now compare and find out which one has the least burst time. Obviously, P2 has least burst time, that is 2 units, right? So P2 will be selected for the execution and P5 will be preempted. Okay, now when it is preempted, P5 is preempted, what happens? out of 4 burst time, it will complete 1 unit of time. So the left out burst time for P5 is 3. Okay, now that is what given in this image. Okay, now when t is equal to 6, what happens? P2 is when t is equal to 6, what happens? Okay, I forgot to explain this part. First, P4 is assigned, it completes its execution. P1 will be executed 1 unit of time. Next, P5 is assigned, again it executes 1 unit of time and then preempted. When t is equal to 6 or 6, P2 is executing, right? So that is assigned and it starts its executing. Next, t is equal to 7, P2 finishes its execution, because compared to all other burst time of the processes which are in radio queue, P2 has the least one, right? Least burst time. That's why it is allowed to complete its execution. Then after it completes, now compare the burst time of P1, P3 and P5. P1 has 5, P3 has 8 and P5 has 3. Okay, compared to these, which one has the least one? That is P5, right? 3 is the least one. Now P5 will be assigned and it will be allowed to complete its execution till 3 units of time. So 7 plus 3 is 10. Okay. Now left out processes in the queue are P1 and P3. Now these two are compared. Which one has the least one? P1 has the least burst time compared to P3. Now that process will be assigned for the execution and it will complete the 5 units of time. That means P1 completes its execution. Okay. Next, after 15, here you can see it completes the execution. So 15 plus next is how much? Here 8. 15 plus 8, that is time. When time is equal to 23, P3 finishes its execution. Okay, so that is, it is assigned, it completes its execution. Now you can see in the Gantt chart, P4 assigned and executed, completes its execution when t is equal to 3. P1, it is executes for 1 unit of time and then preempted, then assigned with P5 because it has least burst time. Again it is compared with the next arrival time. So P2 has the least burst time compared to P5. So P5 is preempted. So it executed 1 unit of time. Then P2, it has burst time as 2. So 2 unit of time it will execute. So 5 plus 2 is 7. Next process has the least burst time is P5. That is its execution time, burst time left out is 3. 7 plus 3 is 10. Next least burst time process is P1, that is assigned and it completes its execution. The left out burst time is 5. So 10 plus 5 is 15. And the last one is P3, which has 8 as burst time. So 15 plus 8 is 23. Okay. This is how what the principle of preemptive shortest job first applied, and this is how the processes will be executed. Okay. For the same, we will be finding waiting time for each process, turnaround time for each process. Once you have these data, you can find out average waiting time and average turnaround time. Okay, so now uh, I hope you followed these problems. Anyways, you have already learned it this right in the last semester. So this is a simple example which I've considered. So now let's move on to the let's move on to the coding part. Okay. So the name is shortest remaining time first. Okay. Also called as preemptive shortest job first. Okay, let's start the code. So here, first, the main function where I have created the processes with the process ID, burst time, and the arrival time. So I have considered 4 processes: process 1, process 2, process 3, process 4. Okay, and I have created a class called process here, where I have considered the process ID burst time, and the arrival time. Okay, with the help of this operator, I've assigned this. The same is called used here, the process. Okay, so where the process ID, burst time, and the arrival time has been assigned. Okay, for all four processes, process ID, burst time, and arrival time has been assigned. Okay, after this, I am calling find average time. Okay, for which I am passing this process list and the length of the processes. Okay, I'll directly go to the find average time function. So here, so it's same as the one which we discussed in the last class with respect to, round robin. Okay, so the logic is quite different. Okay, so here, when this function find average time is called, I have declared the required variables and required array. That is, you have to find waiting time, right? Turnaround time, right? To find average, you need to know what is total waiting time and total turnaround time, and it has been initialized to 0. Now I'm calling the function find waiting time. Okay, so this particular function is written here. Okay, so let me increase the size. Okay, so here, huh, shortest job first, the algorithm name. Here I'm finding the waiting time of each process. Okay, first what I'll do, I'll declare or I will use an array that is remaining time. Okay, this one array I'm using because what process burst time, it will change, right, when it executes. When we apply the logic of this algorithm, it executes and the burst time will changes as time progresses, right? So to keep track that, I'm just copying the burst time of each process into another array, that is remaining burst time. Okay, and I'm using one more array complete, that is to check the completion of all the process execution. Okay, and to keep track of the time, I'm using t, and one more variable I'm using here, that is uh, min m, right? So and minimum, take it as minimum, and I'm assigning that with the integer dot max underscore value. See, I'm assigning this value initially to this because this integer dot max under value, it represents maximum positive integer value. Okay, so this means that no number of type integer that is greater than integer dot max underscore value takes the value like 2147483647. So this is the value that is used in Java for integer. Okay, that is greatest number. Okay, so I'm just assigning this value to minimum. Okay, another one, shortest, to find which process is having the shortest burst time. Okay, and you need to know the finish time to calculate the waiting time, right? And another boolean variable called check, initially it is assigned to false, and this is used to check whether the particular process has completed the execution or not. Okay, so that is about the variables declared for this particular function. Next, we'll start accessing all the process that is present in the ready queue. That means we are going to check all the process from the beginning. Okay, so to do that, I'm using while loop, and I'm checking with whether the complete is not equal to n. N is number of processes. Okay, the first thing is what you have to find at the given point of time. You have to find minimum remaining time, or you can say the process which has the least burst time, that till the current time, right? So to do that, what I'm doing, you have to search with all the process, right? For that, I'm using for loop, and to find the minimum the process which has the shortest job, I'm using the condition like arrival time. I'm checking the process arrival time, is it lesser than or equal to t. Okay, so that is current time. And the burst time of that particular process, is it lesser than the minimum? Okay, along with that, I'm checking whether the burst time is greater than 0. If this condition holds good, the process which satisfy these condition, then I'll be treating the burst time of that particular process as a minimum, and that particular process as the shortest, and condition, check will be assigned to true. So the particular process is considered as the process which has the least burst time. Okay, so I'm just checking where the check, if the check is equal to false, if any process is not if any process was stopped, then we are just incrementing the time and continue. Actually, this will not what to say, we will not check for, such scenario will not come, you can just skip it off. And then once you know the process which has the least burst time, you will reduce what the burst time by 1. Okay, because remaining time, that means burst time by 1. And then you will, the minimum burst time will be assigned with the new burst time, that is the one which you have find out the least burst time, the process which has the least burst time, that will be assigned with the min m value. Okay, now if that min m is equal to 0, again that means the process completes its execution, right? So then I'll be assigning a maximum value to min m. Okay, so now if the process completely completes its execution, that means if shortest or job of the process is equal to 0, that means complete the burst time of the particular process is 0, then I'm going to increment complete by 1. That means one process has completed its execution. And then finish time will be current time plus 1. Okay, then you will find out the waiting time, that is finish time minus process shortest burst time minus process, the process which has the shortest burst time, that one, and its arrival time, that will give you waiting time of that particular process. Okay, then if the waiting time of process, the process which has the least burst time, if it is lesser than 0, then I'm just assigning it to 0. Okay, it can't be the negative one, right? That's why if the burst time is not 0, if still it has to be executed, then I'm incrementing the time t is equal to 1. Again, the while loop continues till the condition fails. In this way, what the process with the least burst time, you will find it out, and then you will execute it, and then you will find the waiting time of each process. Okay, once the waiting time you calculated, then what happens here, here it will return the waiting time of all the process, right? Next, the time, next the thing is you have to find turnaround time of all the process. When this function is called, this these lines will be executed, that is turnaround time. How do you calculate turnaround time? That is burst time of each process plus waiting time of each process, that will give you turnaround time. So this turnaround time will return the value here. Okay, and then you are printing it up. Okay, and then you will calculate what is total waiting time and total turnaround time, and then you are going to calculate average waiting time and average turnaround time by using the formula total waiting time divided by number of process, then total turnaround time divided by number of process. So this will give you waiting time of all the process, waiting time of all the average waiting time of all the processes, and turnaround time of all the processes, and average turnaround time for the given set of processes. Okay, so now we'll see the execution of this code. I already what yeah copied the program. So let's execute. Okay, 1 second. So I'm using online compiler for Java. You can use the same, or if you have installed with the what this one Fedora, then you can go ahead Fedora or Ubuntu. Okay, so let's execute. Yeah, you can see 4 processes are given, the respective burst time and respective waiting time calculated is displayed, and turnaround time. And at last, average waiting time, average turnaround time is calculated for the given set of process. Okay, that concludes shortest job first.